Good morning. Welcome to this sneak peek at how Visual Studio's code editor works under the hood. As always, please take some time at the end of this talk to... No? Okay, my clicker does not work. So please take some time at the end of this talk to... Does this work now? No, that's okay. We just... Oh, my PC froze. Let me retry that. Does this work? Yes, it works. Okay, let me retry that. So, I was saying, yes, welcome to this talk. Please take some time to review this talk at the end so we can know how to improve. My name is Etienne. I am a software engineer, part of the Visual Studio team, more specifically, the Visual Studio editor team. So this is the rest of my awesome team. And we are working mainly on the text editor of Visual Studio, along with some productivity tools such as the search feature. And occasionally, we are also working with Copilot. So today, we'll do a small dive into the architecture of the text editor of Visual Studio. I will tell you some cool story that we gone through a few months ago about how we improved the text editor with remote desktop and show you some cool features. So let's dive directly into the architecture of the text editor of Visual Studio. First, when I talk about the text editor, I'm talking about this thing, the place where literally you type your code, not the things around it. So this is what it looks like. That's an oversimplified architecture of the text editor. I will dive into it in a few seconds. Don't worry. But first, you may wonder, why is this so complicated? Why, it's just, it's just a text editor where I type text. Why just not using strings, for example? Well, it appears that strings don't scale well for this type of usage in .NET, or more in general with C++ too. For example, have you ever tried to open a 1 GB file into Visual Studio? Well, maybe it works for you, but trust me, if the text editor was just relying on string, it would not work. And another thing is that in the editor, we want to support, things like undo and redo. If we had to allocate a string every time you type a character, imagine a 1 GB string we had to allocate every time. Every time you type a character, there would be an extra gigabyte allocated. That's just not OK. So we have frame of scalability, running memory, speed, and then we also lack of a bunch of abstraction around it to add, so we can know where are lines and columns and other things. So therefore, we need to abstract everything. And to do that, we start with something called the text buffer. So when you open a document in Visual Studio, your document will get into this text buffer, which essentially contains your whole text documents, and will be able internally to access to any part of your document using either just the character number into your document or lines and numbers. And then all the edit that you change into your document will be handled by what we call a piece table. If you don't know what is a piece table, let me introduce you to that. So a piece table is essentially a data structure made for text editing that has been proven for decades now that is very efficient for memory consumption and undo, redo operation, and so in general, text editing. So the way it works is the following. When you open your document in Visual Studio, your documents will end up into the original buffer, and it won't change. But then every character that you type into the editor will get added to what we call an add buffer, which is just a bag of characters, and we add everything you type into there. Now, all the insert operations such as typing text and delete operations such as removing code from your text documents, all this get gathered into what we call a self-balancing binary tree, which essentially keep track of all your changes and where they are into these buffers. And then with this, we're able to rebuild your whole document and send that to the text buffer in the end. Now, we only have 20 minutes in these talks. I could spend a whole hour onto the piece tables, and I don't have this time. So if you're interested to learn more, I invite you to scan this QR code, which gives you access to a 30-page PDF written by Charles Crowley from University of New Mexico back in 1998. And yes, it dates, but it's still actually very valid today. As far as I know, Microsoft Word used the piece table since the 80s. And all the other text editor that I'm aware of are using pstable, such as Visual Studio Code. And I'm willing to bet some money that the Apple's Xcode and JetBrains project also use pstable to animate the text editor. So let's go back into our text buffer and our pstable. So we saw that now every time you do a change, we also do what we call text snapshot, which are essentially immutable representation of your text document at an instant t, or more when I say t is basically a character that you type. So for every character that you type, we take this snapshot and we gather many information such as what's the difference between this snapshot and the previous one. So what's the difference between your current document and the character you just typed before. These snapshots are used by what we call language services. So you may know that with Visual Studio, we support C#, C++, HTML, and many things. All these are powered by what we call language services, which are specialized for a specific programming language. And they will rely on this text snapshot to be able to determine what colorization should be applied to your documents, what should be fed into the auto-completion list, where are your errors, where are your warnings, and where to highlight them into your code. So we provide them all this, and then they give us back a bunch of information. And finally, we display the text into what we call a text view. If you are familiar with WPF or HTML in general, essentially the text view is a gigantic canvas in which we display everything, text, line, whatever we need to display. So yeah, mainly we'll display the colorized text, but also, for example, the indication that you have some warning or error into your code. All this is essentially draw. Now, this was just for an overview of the architecture. We'll talk a little bit more about the text view, and I would like to tell you here about like a sort of behind the stage, making of something that we worked on recently into the text editor, and it's how we optimize Visual Studio in remote desktop. And I'm curious, I kind of want to know, raise your hand if you use Visual Studio using like remote desktop, like maybe DevBox or just connect to a server at home. Nice, I see there are a few hands. So if you don't know how remote desktop works, let me try to demystify it a little bit. So you, on your computer, you are the client. And we use when you connect to remote desktop, we use what we call the remote desktop protocol, RDP. Every time you type a character on your keyboard, this character or this information is sent to the RDP server, which is where you have your dev box or your virtual machine somewhere. And then this key being pressed is handled by WPF. And if you don't know, Visual Studio is made with WPF in terms of UI. So if you are really not aware, WPF is a UI framework on Windows. So Visual Studio ultimately will handle that, and we'll go through the text buffer, text snapshot, blah blah blah, and we'll render the change into the text view. Now WPF will naturally find out that something has changed and do a render, and then this render will be sent back to you, the client. Now, to go a little bit more into detail, but still oversimplified, how does this work for sending back the information to the clients? Essentially, WPF will tell to the remote desktop protocol codec that a specific area of your screen has changed. So then the RDP will scan this rectangle that is essentially on your screen, for which the WPF tells that, hey, something has changed. So it will scan every pixels of that, and it will try to determine which type of encoding it should use in order to send the information back to your client, so you can finally see what's changed on your machine. And here is the performance issue that we find into the text editor of Visual Studio and that we solved. So you see, whenever I type a character on this line, for example, you will expect that only that part has been updated. But in reality, we also updated what we call the structure guideline, which is this vertical line here that indicates where are your braces. And we also update what we call the squiggles, which are these waves under a piece of code that tells you where are your warning and errors, which gives that whenever you type, you get something like this. So as I'm typing on this line, we can see that all this rectangle here is being updated, which means that then the RDP has to treat all this area. And even if visually for you, the customer, you don't see anything that has changed, the WPF actually re-render all that. And that costs us some time because the RDP has to work on scanning all these pixels. So how we improve that? We use some caching. So essentially, we are determining whether the structure guidelines are supposed to change or not, whether the squiggles are supposed to change or not. And if not, simply we don't touch to them. And then the Canva is able to tell the WPF that, hey, this thing did not change. And meanwhile, what we were doing before is that we actually were kind of clearing the Canva and redrawing most of it again. So once the optimization was done, that gave these results, where on the left, you can see that before we optimize the structure guideline, we had this whole column being updated. And after optimization, you can see that this whole column is not being updated anymore. I talk about the squiggles, about how the errors also need some optimization. In this particular GIF, the optimization for the squiggles were not done yet. But today in your Visual Studio, the optimization is there. So essentially, you only have this horizontal line that is being re-rendered by WPF, and that's it. So how much we gain of that? So we tested multiple network conditions, and we found out that in the base network that we were able to test with, we were seeing an improvement of roughly 10 milliseconds of latency from the time you press a key on your keyboard and see the change back on your machine. And in the worst network condition that we tested, we saw an improvement of 60 milliseconds, which is pretty significant when your connection is pretty slow. So yeah, and pretty cool. Now, how do we make sure there is no regression? How do we make sure that these issues don't happen again? We have two ways to test this. The first one is the WPF performance suite. It's essentially the tool that we use to see this rectangle that appear whenever the WPF do a render. It's part of the Windows 7 SDK, so it dates a little bit. It dates from the time where the WPF was created. And yeah, that's only a software test, so we can only measure Visual Studio itself, like where are the rendering happening. Now, for the end-to-end tests, we have a tool called Mr. Clicky. And Mr. Clicky is an internal tool developed by the Xbox team that they allowed us to use for Visual Studio. And on this tool, essentially, we have some device that will press on the keys of your keyboard. And then we literally have duct tape a light sensor on the monitor to detect that something has changed on your screen. And then we have some software that basically measures how long it took. And so with this, we're able to not only measure the latency of the RDP, but also the latency of just your keyboard and the latency of your monitor, because this one has a refresh rate. So yeah, pretty cool. That's kind of the highlight of this demo, honestly. Now, I'm very happy that I was able to tell you about this, but it's actually not my work. It's the work of my super coworker, Amadeus, which I think we can clap because he spent many months at working on that. So yeah, congrats to Amadeus. All right, now how about I tell you about some cool feature that you might not know in Visual Studio. I hope this is not a surprise for you that we use some telemetry to monitor a little bit the usage of Visual Studio. And thanks to this, I'm able to tell that there are some features that are really awesome and that you folks don't use. I'm very ashamed of that. So let me show you this. And instead of showing you like a sort of boring PowerPoint, how about I jump directly in Visual Studio and show you all that? So where did my screen go now? Let me share my screen again. Here we go, it comes back. So don't worry, I prepared in advance. I have a tiny tool at the bottom of my screen, which makes that when I press some keys, you can see what I'm pressing, so you can learn the keyboard shortcut with that. All right, so the first thing, I have a whole list of things I want to show you. The first thing is code search. So if you go, for example, on just on this line and press Control, comma, you can have this window that appear and allow you to search for code. So it's not only finding files where you can just search plain text. Here you can search things for like symbols, which is essentially method names, for example, or like class names. So let me search one, for example. You see here I have like end of line sequence. Let me search that, but with a typo. End of line sequence. And I did on purpose to put a typo just to show you that we actually have some sort of fuzzy match, which makes that even if you do a typo, we're able to find what you want. And this is what I want here. Obviously, it's not at the top because I have a typo, but if I remove my typo and type it correctly, now it's at the top. Awesome. Similarly, if you want to search for a feature, you can press Ctrl-Q. And now you can type something like numbers, and I will be able to turn on or turn off the line numbers that are on the side of my editor. Next one is Ctrl-G to go to a line. So for example, I can type, I don't know, 20, and now my caret will go directly to the line number 20. The next one is previous and next reference. So let's say that I put my cursor on this, the end of line sequence. If I press Ctrl-Shift and up or down, I can navigate to the reference to that symbol within my text documents. And so, yeah, I can keep pressing down, down, and I will jump to all of these. Similarly, let's say caret movement. I can also do Ctrl-Alt, left, and right, not to just, for example, if I do Ctrl-Right here, hopefully you see my carets up. If I do Ctrl, let me zoom even more. There we go, to make sure it's clear. So if I do Ctrl-Right, you will see that my caret that is right here will jump directly to the right of the word. That's very common. You can do that in Notepad, Word, whatever. But what about if you want to jump to a subword? You can do Ctrl-Alt, right. And now I just jump to the next subword of my symbol. This can be very nice if I want to, for example, select just a part of it. Now we press Ctrl-Alt-Shift and right, and now I select just the next subword. Similarly, on the left, I can unselect and select again. Nice. Next one is multi-line selection. I'm curious, who know here that you can select multiple lines, but like vertically, just not by dragging? Now I see a few hands, cool. So if you don't know, you can put a cursor, for example, here and press Alt and then down. No, sorry, that was Alt-Shift down. That was the next demo. OK, so let me do Alt-Shift down, and now I have multiple carets that appear. And with this, I can, for example, press / to comment everything. Can do that on multiple lines. Similarly, what if I want to move this whole block of code? I can press Alt up and down to move them from a line down below. So now I press Alt down, and my whole block of code move. Of course, here I'm introducing some syntax errors. All right, now what if I want to duplicate this lovely line? I can go on this line and press Ctrl-D, and now it's duplicated. Similarly, I can press actually not similarly, but if I want to remove this line but put it into my clipboard, so essentially cut the line, I can press Ctrl-L. And now it's into my clipboard, and I'll be able to just go there and paste it because it's in my clipboard. But if I want to just delete this line without putting this into my clipboard, I can press Ctrl-Shift-L, and now it's just deleted without being into my clipboard. Yes?
I noticed I use Ctrl-L all the time, and in Visual Studio Code it doesn't do it. Something different?
So the question was that this person used Ctrl-L into Visual Studio Code instead of Visual Studio, and you say it doesn't behave the same, right? So I do admit I'm an engineer specialized on Visual Studio, not Visual Studio Code. So I don't have a direct answer for you here, but it might have to do with maybe keyboard mapping. You can always, I think, customize the keyboard shortcut into Visual Studio Code or Visual Studio to adjust your keyboard shortcuts.
I was curious how people draw compose line.
Oh, yeah, there's some profile that you can use into the settings. So next one, we have renaming a symbol. I don't know if you know this, but you can go on what I call a symbol, which is essentially a method name or a class name. And let me go on this one. And I will press Ctrl-R 2 times. And now I can rename this whole thing with all the references where it's used. I have Copilot that also suggests me some change potentially. like this one. Let me do, for example, detect line break. And as you can see, this method is used on my line 18. I will do detect line break, and I will just press enter. And now all the places where this method used has been renamed. So I don't have to go through all the places where it's used and rename it myself. Next one is commenting and uncommenting. So I know you folks, based on telemetry, I know you folks love Control-K, Control-C to comment a line. But I prefer personally Control-Shift. Sorry, Control/. There we go. So Control/, the difference that this one toggle the comments. So if I press Control/ again, it will uncomment. And I can also do that on a block command. So if I press Control-Shift/, it will do a block command. And similarly, I can remove the block command with the exact same keyboard shortcut. Here we go. Next one I have for you folks are Copilot. I know you heard a lot of Copilot this week. I'm sorry, we are not done here. So the first one I have is the inline chat. I don't know if you know, but you can select a piece of code and do right-click and ask Copilot. And you will have an inline chat directly there. But I can also just simply get there and press Alt/, and now I have Copilot that appears there. And I can ask, for example, I don't know, create a description for this method. Whoops, description for this method. And it will just do it. So maybe I can wait a little bit here. I know I'm running out of time. This is the very last thing. All right, and I can just press Tab to accept. Another thing, if I actually remove this line, now I can go here and press Alt:, to, oops, sorry, Alt:, I said, not Control:. Right, Alt:, and now I essentially manually triggered Copilot to try to ask Copilot to give me some suggestion of my code. And there you go, I can press Tab to accept. All right, if you don't think you had enough keyboard shortcut, there are many more here. I invite you to take a picture of that if you want. You can also find it on the Microsoft Learn website. That's where I literally took this image from. And yes, that was it for my talk. Let's stay connected. My name is Etienne. It was my pleasure to talk to you today. And please take some time to rate this session. Thank you very much.